plus is just like 0.00001 and so on. Okay, and this 0's minus is just like minus 0.00001 and so on. Okay, we will know now why did we put it 0 plus, not 0 in general. If we had a limit x approaching 0, this means that the limit approaching 0 from right must be equal to the limit 0 approaching 0 from the left. You are not indicating here which direction. So when you are not indicating what direction you are going or you are approaching to 0, you are telling me that it doesn't matter. You choose it like this direction, you choose this direction, it will give the same answer. So when we write this, x is approaching 0, we mean that the approaching 0 from the right is equal to the limit approaching 0 from the left. Anyway, it will not matter for the steps of the solution of the problem. If we have this limit, we have learned the first step is to substitute directly in the problem. So we'll have here 0 power sine 0. What is sine 0? Sine 0 is 0. Sine 0 is 0. So this is 0 power 0. طبعا انا باكد تاني ان انتوا لو في حد متضايق من الانجليزي فانا في المحاضره بتاعتي يوم الاربعاء الاولى، وفي ناس منكم بيحضروا معايا الاربعاء الاولى. فلو حد يعني الانجليزي بالنسبه له عامل له ازمه، عامل له مشكله، مش حاسس ان هو مش بيفهم 100% او الكلام ده، فممكن عادي يحضر يوم الاربعاء الاولى في السكشن اللي هو او في الفصل اللي هو قصاد ده على طول. الفتره الاولى من الاربعاء، الفتره الاولى من الاربعاء تحضر في الفصل اللي قصاد ده. تمام؟ طيب. Let's return to our problem. So this will give me 0 power 0. This will give me 0 power 0. I must first, if I'm going to apply L'Hopital's rule, I must check, or I must be sure at first that it is one of the 7 indeterminate quantities. I must be sure that first it is one of the first and the 7 undeterminate. What are the indeterminate quantities? ايه؟ هتطلعي ولا بعد؟ انت عملت كده ليه؟ مش انت ولا وراك؟ انتوا كلكم عربي ولا في حد انجليزي؟ you're only English. Any other one is English؟ تفهمي عربي انت ولا لا؟ فاهمة عربي؟ طيب ماشي. So what are the 7 indeterminate quantities? They are 0 over 0, infinity over infinity, 0 times infinity. We have also infinity minus infinity. Then we have 3 in the form of something power something. It will be 0 power 0, 1 power infinity, and infinity power 0. What about 0 power infinity? No, 0 power infinity is not indeterminate quantity. This is equal to 0. Why? It is 0 times 0 times 0 times 0 infinite times. You are multiplying 0 infinite times, so it is infinity. Every one of these, you will find that there is some خناقة بالإنجليزي اسمها إيه؟ Some إيه؟ حد يعرف؟ عايز أقول خناقة. Struggle, fight. Yes, there is a fight. There is a fight between 2 laws here. For example, if you had 0 over 0, 0 over anything is 0. Anything over 0 is infinity. So we have a fight between these two. Infinity over infinity. Infinity over anything is infinity. Anything over infinity is 0. So we'll have a fight, and so on. Each of these, we will find there is some fight between both of them. 0 power 0. If we have 0 power anything is 0. But anything power 0 is 1. So each of these wants the result to be something, so we'll have a fight between both. There is only one thing that is different, which is 1 power infinity. You may think about it, 1 times 1 times 1 infinite times, it will be equal to 1. Okay, but this is not the case. This is not equal to 1. This is not equal to 1. What will it be? This will be, or if this is exactly 1, now we must know that when we are talking about limits, this is not the exact 0. When I say 0 over 0, I'm not talking about the exact 0. I'm talking about infinitesimal 0. Infinitesimal 0 is something like this. 0.0, it is something that is moving, a number that is moving. It is approaching 0. It is not the 0 itself, it is a number that is approaching 0. Okay? So, when I'm talking about this one, this is not exact 1. This is not exact 1. If I say, for example, 1.0000001 power infinity, what would be the result in this case? It would be infinity. If you just add a little bit of number 1.00001, add just a little infinitesimal bit of number like this, and you make it power infinity, it will go to infinity. But if you make it like this, 0.999999999 and so on, power infinity, that is a fraction. In this case, it's now a fraction. When you take it power infinity, that will be 0 in this case. So, just a little perturbation in the 1 makes the value goes from 0 to infinity. Okay, so we have here also some fight between both of them. Okay, so anyway, these are, in this case, there is no fight here. There is no fight here. 0 times 0 times 0, this will be a 0. Okay, infinity power 0, no, but infinity power 0, there is a fight. Why? Infinity power anything is infinity. But and anything power 0 is 1. So we have a fight. So this is indeterminate quantity. How do we determine it? By the limits, by the procedure we make, by L'Hopital's rule, by any of things that we are learning here. Okay, now let's check this problem. We want to solve this problem. Limit x going to 0. Now we make a direct substitution and we found it 0 power 0, and this is one of the indeterminate quantities. Indeterminate quantities. How will you solve it? Any of the three indeterminate quantities that in the form of something power something, we make it by taking ln both sides. Okay, so I will call this limit L, I will call this limit L, and I will take, I need to know what is L, what is the value of L. So I will take ln L. Ln L, do you remember ln? Ln, the natural logarithm. The natural logarithm. Ln is the natural logarithm. So this will be ln limit x approaching 0 of x power sine x. Now there is a rule that tells me that ln of limit is the limit of the ln. Ln of limit is ln of the, so this will be limit x approaching 0 of ln x power sine x. And ln x power sine, that will be, the sine will go beside the ln. So that will be limit x approaching 0 plus sine x ln x. Now it's my goal now to solve or to find the value of this limit using L'Hopital. Would I need to check if it is undetermined quantity? No. If it started with an indeterminate quantities, any procedure you make wouldn't change it. It will may change from other form to another form. For example, this will change to this form, 0 by infinity. So any mathematical operations you make on some indeterminate quantities, it will become another indeterminate quantity, or another form of the indeterminate quantity. So I don't need to check again if it is indeterminate quantity. Okay? So anyway, if you are in this result, you have determined that you can apply L'Hopital's rule. We have learned before that L'Hopital's rule cannot be applied unless you have an indeterminate quantity, and that's why in each problem we need to check if it is indeterminate quantity. Okay, I've checked it, and L'Hopital's rule can be applied. Okay, so in this case it is applied here. But we have learned that to apply L'Hopital's rule we needed to make it in some form. Do you remember? In a form of numerator or denominator. We need to put the problem in a form of numerator or a fraction, like a fraction. And do you remember? One of these will move. I can write it sine x over 1 over ln, or I can write it ln x over 1 over sine x. What do you think would be the more suitable or the more convenient way to write the problem? This way or this way? Do you remember? I've told you some rule in the last lecture. Yes, ln over 1 over sine. Why? I've told you to remember that ln is heavy. It doesn't move. It stays in its place. It stays in its place. And we have len is very heavy. Above it there is algebraic, and then the exponential, and the trigonometric. Trigonometric and exponential, these are very light. The exponential and trigonometric are very light. They move freely. Then we have the algebraic in between the len n and the exponential. Then the heaviest of all of these is the len. So it doesn't move. Okay? So in this case, I will just rewrite the problem again to be like this. It will be limit x approaching 0 plus len x over 1 over sine. What is 1 over sine? We have learned the reciprocal of sine. What it's called? It is called, yes, cosec. But this will be cosec x. Now I'm ready to apply L'Hopital's rule. Do you remember how to apply L'Hopital's rule? We differentiate the numerator by itself. What is the derivative of len x? It will be 1 over x. And what is the derivative of the denominator, cosec x? What is the derivative? It is negative cosec cotan. Okay, now before substituting with 0, I will just rearrange the problem. So that will be limit, I just write it in pink. Limit x approaching 0, that will be 1. I will take the x and make it down in the denominator. There is a negative, and cosec is 1 over sine, so it will make it sine above in the numerator. And I have cotan, which have cosine in the denominator over some sine, so that will be sine squared. So this is the new form of the function in this case. Now I'm ready to substitute. When I substitute, it will give me 0 over 0 times 1. Do you remember the rule I told you? Whenever you make a substitution, multiplication and divisions, and I find some of the factors give me numbers that are not 0 or infinity, I just take it out. Why? To simplify the problem. So in this case, this cosine will go out, or this one will go out. So I will just remain the problem. I'll just take it in another page. So I just made my substitution, and I found it to be 0 over 0 times 1. And I found that this one, I can take it out. So the limit will be x approaching 0, that will be minus, I'll take the minus outside, sine squared x over x. Now it is 0 over 0. And I can reapply L'Hopital's rule, because it is 0 over 0, it is indeterminate quantity. And that's why it is better to get rid of this cosine, so that you make the expression of the function simpler, so that when you differentiate another time, it will be a simpler problem, not a complicated one. So in this case, that will be negative limit x approaching 0 plus, and that will be 2 sine x cosine x over 1. Now I substitute with 0, so that will be 2 times 0 times 1, and the result will be 0. Now remember that this is just len of L. So I've deduced that len of L is equal to 0. What would be the L? What if len L is 0? What would be the L? How do I get rid of this len? What is no? Yes, it would be, the result would be 1. But how do I get rid of the len? By its inverse. What is the inverse of the len? It is e power. Yes, so I take e power both sides. That's why e removes the len, so that will be L, and that will be e power 0, and e power 0 is equal to 1. So that is the result of the limit. Okay, that is exactly the way we proceed in any problem in these any of these forms, any of these three forms that are in the exponential form. something power something. Okay? In the indeterminate quantities, we make len both sides, solve the problem, then we get e power the result that we have got. Okay? So that was a problem from the last lecture. Now today we're going to take a new topic, which is inverse functions. Inverse functions. We have touched this topic before. We know, for example, that the len is an inverse of the e, and we know that the root is inverse of x squared. These are two operations that cancel each other. Two operations that cancel each other. For example, root squared is nothing. Len e power something is something. So no, as if there is no operation on that thing. Okay, so that is an inverse operation. That is an inverse operation. For example, if I had y is equal to x cubed, I need to find the inverse. How to find the inverse of this problem, of this function? How to find the inverse of this problem, of this function? Okay, let's check. When I what is f of 1? What is f of 1 in this case? It is 1. What is f of 2? It is 8. And f of 3 is 27. Yes. What is an inverse operation? An inverse operation, it is a function that takes the outputs. When I say f inverse, what is f inverse of 1? It is 1. What is f inverse of 8? It is 2. What is f inverse of 27? It is 3. Now let's check the points of this function and the points of this function. The points of this function are, this is 1 and 1, and this is 2 and 8, and this is 3 and 27. What about this function? That will be, the points of this function would be 1 and 1. The input is 1, the output is 1. The output is 8, and the output would be 2. If the input is 27, the output will be 3. What do you notice between these two sets of points? There is a pattern here. There is a pattern here between these two sets of points. What is the relation between this point and this point, for example? Yes, they are swapped. They are swapped. Yes, as if x and y are switched or interchanged. And that is exactly what the inverse function do. The first step in how to find the inverse function is to interchange x and y. Is to interchange the x and y. So that's why if I need to find the inverse of this function, I interchange x and y. I say x is equal to y cubed. Then I solve in y. Now this is the new function. This is the new function which is inverse. This is the new function which is called inverse. Now I need to find it. What is y? What is the inverse? What is the inverse in this case? I need to find it. So I need to solve this equation. How to solve this equation? Y will be cubic root of x. And that is exactly the inverse function of the x cubed. Okay, so this is the procedure to find the inverse of any function. For example, if I had, for example, y is equal to cubic root of x, x power 5 plus 3, and here is minus 4. I need to find the inverse of this function. How would I find it? The first step is interchange x and y. So that will be x is equal to cubic root y power 5 plus 3 minus 4. Now, what is the next step? I need to solve for y. Now this y is now the inverse. That is my unknown. This is my unknown in this case. I need to find the y. So I need to make it in one side by itself. How would I do that? So I just get rid of this minus 4, so that will be, I'll just rewrite it like that. Cubic root y power 5 plus 3 is equal to x plus 4. Now I want to get rid of this cubic root. How would I get rid of it? by its inverse, which is power, yes, power 3. I will take power 3 both sides, so that will be y power 5 plus 3 x plus 4 all power 5 or power 3. Now I want to get rid of this 3, so I take it to the other side. That will be y power 5 x plus 4 all power 3 minus 3. Then I want to get rid of this 5. How would I get rid of it? By fifth root. So that will be y equal fifth root of x plus 4 all power 3 minus 3. And this is exactly the inverse function. Okay? So we have learned how to analytically find the inverse of a function. Okay? Now I need to know how to geometrically find the inverse of some function. If, for example, if I know that I have this function, for example, this function. The function, there is a condition for any function to have an inverse. It is called the function must be 1-to-1. A function must be 1-to-1. What is 1-to-1? A 1-to-1 is checked by something called the horizontal line test. We have learned that a function must satisfy the vertical line test. Do you remember that? The vertical line test, which was to identify if it is a function or not. Okay? Now there is another test, which is called horizontal line test. That horizontal line test, it is for determining if it has an inverse or not. This, for example, this is not 1-to-1. Not 1-to-1. So if it is not 1-to-1, it doesn't have an inverse. Does not have an inverse. Have inverse. We will treat with functions like these to make it 1-to-1. We will learn now how to make it 1-to-1. But at first, any function, in order to have an inverse, it must be 1-to-1. What does it mean? It means that it must satisfy the horizontal line test. What do you think about this function? Does it satisfy the horizontal line test or not? I take horizontal lines. Do I have any more than one intersection? No. So it is satisfied. This is 1-to-1. So it has an inverse. This function has an inverse. Okay? How do I find the inverse? We have learned that to find the points. Now this is the function. It has points. This is the curve. The curve is consisted of some points. Now I need to find the curve of the inverse function. The points of the inverse function. What are these? Do you remember? If we have swapped, so if, for example, if I have this point which is called -1 and 0, I will have another point for the inverse which will be 0 and -1. I swapped the x and y and so on. If I have this point is called 0 and 1, for example. So I will have in the inverse, I will have another point which is called 1 and 0, this point. 1 and 0, which is this point. So how do I find all of these? It is simply got by a reflection about this line, which is called y equals x. So when you make a reflection about y equals x, it gives me the points of the inverse. Okay? It will give the point of it. So what would be the new inverse function? It would be like this, a reflection, as if there is a mirror about this green line, a reflection. Okay, so I've learned how to find the inverse analytically. We have learned how to find the inverse geometrically. Okay, now how to treat just before this, we have interchanged x and y. So whenever we have an inverse function, if we have an inverse, y is equal to f of x. If this function has a domain df and has a range rf, what would you expect would be the range and the domain of the inverse? What would you expect? We have learned that the domain is the values of x, okay, that are allowed for the function, the values of x that are allowed in the function. But you have interchange, for the inverse, you have interchanged the x and y. So what would you expect would be the domain? It would be the range of the inverse. Why? The range, it is the interval that deals with the y. Okay? This is the x, but you in the inverse operation you have interchanged the x and y. So the domain will be the range, and the range will be the domain of the inverse. Okay? So these will be interchanged like this. So that will be the range of f, and that will be the domain of f. Okay? So how would we deal with a function that is not one-to-one? For example, a very known function which is x squared. This is a function that is not one-to-one. Does it have an inverse? No. It doesn't have an inverse. It doesn't have an inverse. Why? Because it is not one-to-one. Not one-to-one. So it doesn't have an inverse. Does not have an inverse. Okay. Then you think, but I know that there is the root. The root is the inverse of x squared. I'll tell you, no, hold on. The root is not the inverse of the x squared. But we treat that x squared by a trick to make it one-to-one. How would I do that? It tells me that we will restrict the domain of that not one-to-one function so that it would be one-to-one. You would restrict it in a way that makes it one-to-one, and also that covers the whole range of the original function. So, for example, I would restrict it, I will just take that part. The positive part. What is that blue function? It is called f of x is equal to x squared, but there is some imposed domain. There is some restricted domain. I will say here, that is, I have a condition that x is greater than or equal to 0. So this is a different this is a different function from this one. This function is different from this one. Okay? So now I need to ask you, can I make the restriction like this? Could I take that part of the function? Why not? It is not one-to-one. There is some parts that it's not one-to-one. So this is rejected. This is not suitable as a restricted domain. What about taking this part? Taking this part only. Now it is one-to-one. But it is still not suitable. Why not? Because it just covers a part of the original range. Yes, we need to make our restriction. I want to make it to cover the whole range of the original function. Okay? To be suitable for me. If you take it just like this, so this will be a gap in my function. It will be a gap in my function that I cannot deal with function that in this part. So that's why this is also not suitable. What about this? If you take it, this red. Is it suitable? Yes, this one is suitable. But it is a convention. They have chosen it to be the right side, the positive side. Maybe in some other planet, they may have chosen that side, but on planet Earth, we have chosen it to be the positive side. Okay? So this is called the restricted x squared. What is a restricted x squared? This is x squared restricted. X squared restricted. What is restricted? It is an x squared that has an inverse. It is an x squared that has an inverse. Okay? Now what is the inverse in this case? That will be y is equal to x squared and x is greater than or equal to 0. Now I interchange x and y. So that will be x will be equal to y squared. And I also interchange the condition. So that will be y greater than or equal to 0. Now I need to solve for y. If I solve this for y, I will get y is equal to plus or minus root x. But I have the condition that y is greater than or equal to 0. I know that the root is always positive. A root is always positive. So, is this negative? Is it suitable for this condition? No. So I reject the negative. I reject this negative. Negative is rejected. So I just have one choice, which will be y is equal to root x, which is the inverse, and y is greater than or equal to 0, which is the inverse of x squared. X squared restricted. So whenever I have an not one-to-one function, the first step is to restrict its domain and deal with the restricted function. Then I make the inverse function that I need. Okay. Now we need to make a difference between these two cases: root x squared and root x all squared. This is just like saying f inverse of f of x. If I assume that f of x is x squared, so that will be f inverse of the f of x, okay? And that would be the f inverse, the f of f inverse. Could you identify what I'm saying here? So if I assume it like this, it would be, now, what would be the result in each case? Let's start with this one. Now, what is the domain of this function at first? What is the domain of this function? Yes, it will be r positive, or x greater than or equal to 0. Why? Remember, when you need to find the domain, you find the domain before making any simplifications. You make it before making any simplifications. So we have here an x inside the root. Whenever I have an x inside the root, what is inside the root? It will be positive. I make it positive or 0. X greater or equal to 0. Now, after I have put this condition, now I can simplify. What would be the result? The result will be as if this cancels this, and that would be x. But I need and I must put this condition, x greater than or equal to 0. So what is the graph of this function? It is not the conventional x, which is like this. No, this is x, but only on the positive side, x greater than or equal to 0. This is this one, but not this. Okay? You understand what I'm saying? So, what is the result now? If we need to find the result of this function, f inverse of x. The result is x. As if this cancelled this. But I have a condition. What is the condition of this rule? That x belongs to the domain of, now this x is inside the f inverse. Okay, so x must be in the domain of the f inverse. X must be in the domain of the f inverse. Okay, x must be in the domain of the f inverse. Now let's check that other case. Any of you know what is root x squared?
Plus or minus x.
No, not plus. Now remember, this is a function. A function doesn't have two values.
Absolute x.
Yes, it is exactly. It is absolute x. It has a result that is always positive. A root gives only positive values. It doesn't give me negative. Never gives me a negative value. Maybe solving an equation gives me a negative value. If I told you, solve this equation, x squared is equal to 4. Yes, I may have negative root 4 as a solution in this case. As a solution of an equation. But if I need to find the value of a root is one value and it is only the positive value. Okay? I need to emphasize about this point. Now, let's check this. Do you remember how to write it in another form? Do you remember? We have written the absolute x as x when x is greater than 0 and negative x when x is less than 0. Do you remember this form? This is another form for absolute x. Now just remember that this formula gave me an x, or if I need to say it, that f inverse cancelled the f only and gave me an x only in some condition. What was the condition? If x is positive. But whenever you are outside this condition, you may get another form. You may get another form. So when do f inverse cancels? When f inverse cancels the f, it is when x belongs to the restricted domain of f. The domain of f. This is in the restricted domain of f. Whenever you have a restriction. If you don't have a restriction, if the function it was 1 to 1, so the result will be x always. It will always be f. But whenever you have a restriction, like the x squared was restricted. X squared was restricted. Okay? So now we apply the root of x squared. Now just take care. You don't cancel these by each other. You only cancel them in one case when you are inside the restricted domain. What was the restricted domain of x squared? Do you remember? It was only the positive side. So this will give me only x, in this case just only when x is greater than 0. When x is greater than 0. But if you are outside the restricted domain, for example, if I give you f inverse of f of x, and this x is outside the domain, for example, for x squared, I give you a negative number. I give you a negative number. Root of negative 3 all squared. Would the root cancel the square? Would give me negative 3? No, this is a wrong answer. A root never gives me a negative. So the correct answer for this is 3, positive 3. Is it exactly the x? No. Why didn't the root cancel the squaring? Because you are outside the restricted domain. Because you are outside the restricted domain. So whenever you are outside the restricted domain, the cancellation doesn't apply. The cancellation of inverse when you take it in this form. So as a summary for all I've taken here, if I have f inverse of x, these would cancel each other, but I give x must be inside the f inverse, so that will be x inside the domain of f inverse. For f inverse, and just make it as a model example in your mind, the root x squared and the root x all squared. Okay, for whatever the function we will study afterwards, for f inverse and f. Okay, so for example, this f inverse of f of x, that will be x only in the case of x belongs to the domain of f. Restricted. But you know here that I may have other values where when you are outside for x that does not belong to df, I may have a value. In contrary to this, in this formula, I cannot be outside the domain of f inverse. I cannot be outside the domain of f inverse. Okay? But in this case, I may be outside the domain, the restricted domain. I may be outside the restricted domain. But you know that if I'm outside the restricted domain of f, the result would be different from x. In that case, the result was negative x. In this case, the result was negative x, not x. Okay? If you understood what I'm talking here, what if I told you if I need to find f inverse of f restricted of x like this? What would be the result? Could I say that this result will always be x? What is meant by saying that this is f is restricted? That I am confined to this restricted domain. Would I go out this restricted when I tell it in this form? When I say this is f restricted, can I be outside the restricted domain? Never. So that's why the result in this case will always be x. The result in this case will always be x. Okay? So these are general rules for inverse functions. Now let's learn the inverse functions for the trigonometric functions. We need to find what is sine inverse x. It is called sine inverse x, or it is called arc sine x. But in our case, we'll just say sine inverse x. Now, I need to know that this is different from this notation. We know that sine squared x is just sine x all squared. So is it sine inverse x? Is it sine x all power negative 1? No. So take care, these are different notations. This is a symbol for the inverse. It is not a power. This is just a symbol for the inverse. It is not a power. Okay? So this is not equal to sine inverse x, sine x power 1. Power negative 1, or the 1 over sine x. This is different from that. Okay? What is a sine inverse? Sine inverse is an angle. Sine inverse by itself is an angle. We have learned before, if I tell you what is sine pi over 2, for example, sine pi over 2 is 1. Now if I tell you what is sine inverse 1, it is the angle that has a sine equal to 1. It is the angle that has a sine equal to 1. So that's why that will be pi over 2. Okay? So that is the meaning of the inverse, or what is the meaning of the sine inverse. But we need to make it careful. Why? Because when I said sine, that sine curve is like this. Is this a one-to-one function? No, this is not a one-to-one function. So by itself, this original sine is not one-to-one, so it doesn't have an inverse. This ordinary sine, it doesn't have an inverse. So what do I need to know to find an inverse for it? I need to make a restriction in domain. I need to restrict my domain in order to have a domain that is what is one-to-one and covers the whole range of the function. Okay? So, would I take this for example? No, this is not one-to-one. What about this only? It is one-to-one, but it has a disadvantage.
It is not all the range of...
Yes, it doesn't cover the whole range. How would I choose it to cover the whole range? I just make it like this. And this is my restricted domain of the sine. So, my new sine restricted. The sign restricted. What is sign restricted? Restricted. It has a domain which is equal to from negative pi over 2 to pi over 2. The restricted sign, so this in red, this function in red is called restricted sign. Sign restricted. It has a domain x belongs to from negative pi over 2 to pi over 2. So that will be the sign restricted. It will have this form. Now I need to find the inverse. Let's graph the inverse at first. Let's graph the inverse. I will take this line, and so the inverse would have this shape or this graph. It would be something like this. So this is the graph of sine inverse. Now, for this function, which is sign restricted, it has a domain is equal to from negative pi over 2 pi over 2. Okay, what about its range? What about its range? What is the range of sign restricted? It is the same range of the function. Remember that you have made the restriction in order to conserve the range. It must have the same range. It must cover the same range. So you have, the range doesn't change. When you make a restriction domain, you don't change the range. So for the sign inverse, which is the inverse of the sign restricted, you will have a domain which will be equal to yes, minus 1 to 1. The sign inverse will have a domain minus 1 to 1. That's why when you put sign inverse, what is inside the sign inverse must be from negative 1 to 1. What is inside the sign inverse must be a sign of some angle, which must have a value of from negative 1 to 1. Okay? So this is the domain of a sign inverse. And here will be some new type of problems that I give you some sign inverse of some form, of some problem in X, and I tell you find the domain, sign inverse. So you take what is inside and you put it in from negative 1 to 1 and you solve the inequality. So this is a new problem for domain. This is a new type of problem for domain. We have learned for domain to find the root, 1 over root and 1 over and for a denominator. Okay, so let's return again. If I have, what is the range in this case? The range of the sign inverse. Domain. Yes, the domain of the restricted sign, that will be from negative pi over 2 to pi over 2. So a sign inverse will have this range. What is the range? The range is the set of outputs. So the sign inverse has an output that is always confined between two of these values from negative pi over 2 to pi over 2. It just has one value, which is an angle from negative pi over 2 to pi over 2. What is an angle which is from pi over 2, negative pi over 2, pi over 2? And negative from pi over 2, this is the fourth quadrant, from negative pi over 2 to 0, and from 0 to negative pi. So this, a sign inverse will always be an angle in the first or fourth quadrant. Do you remember I told you that the sign inverse is an angle? Just like the root has one value that is positive, although, for example, I have negative 2 squared is equal to 4, but the root 4 is not negative 2. So I may have some number that which is squared is 4, but this is not the root 4. Also, if I have sign inverse of 1, it gives me one value, one angle. Although I may have other angles that have the sign which is equal to 1. For example, an angle which is pi over 2 plus 2 pi, this angle have a sign which is equal to 1. But would I say that sign inverse is equal to this angle? No. A sign inverse is a function. It has only one value, and that value must be confined between these two values from negative pi over 2 to pi over 2. Okay? So whenever you try on the calculator, sign inverse of some number, some fraction, you find it It will give you one number that is restricted from negative pi over 2 to pi over 2. Okay? What about the symmetry of this function, the sine inverse? The symmetry, is it odd, even? Remember, a rule, the inverse of an odd function is an odd function. The inverse of an odd function is an odd function. So that will be that in pink, that will be an odd function. That will be odd function. So whenever I have sine inverse of negative something, it will be negative, the negative will be got out. Like this. Okay, now if you let's check if you have understood what I've said. What is sine inverse 1 over root 2? Is it pi over 4, 3 pi over 4, 9 pi over 4, 11 pi over 4?
Pi over 4.
Or any of these? It is just pi over 4. It is just pi over 4. It will give me just one angle, which is from negative pi over 2 to pi over 2. These are rejected. This is greater than pi over 2. So these values will never get me an angle like this. What about this one? This is also, yes, that is greater than pi over 2. So this is rejected too. Although this angle, sine 3, if you find the 3 pi over 4, it will give you 1 over root 2. But is it the sine inverse of 1 over root 2? No. Okay? What is sine inverse negative 3x? I can take the negative outside, so that will be negative sine inverse 3x. What about sine inverse? Now let's check this one. Let's check these two. If I tell you sine inverse of sine pi over 3 and sine inverse root 3 over 2 and sine inverse of sine of 3 pi over 4. Now we don't have a calculator, in the exam we don't have a calculator, so we need to find the values of these. Now we have checked, we remember the rules, we have checked just 10 minutes ago. Sine inverse.
ممكن أسأل ما وقت تفهم ميكانيكا الكهرباء؟ ما وقت تفهم ميكانيكا الكهرباء؟
دلوقتي انت الشرح هنا بالانجليزي، عايز الشرح بالعربي ولا بالانجليزي؟ عربي. يبقى تحضر يوم الاربعاء الفترة الأولى.
الساعة كم
الفترة الأولى 8:30. ماشي، هيبقى فين؟ في الوش هنا.
بس
الفصل اللي في الوش. ماشي، تعالى بدري بقى.
بس
تصحى بدري ها؟
بس
ماشي، يلا. Sine inverse sine pi over 3. Now this is the form of this f inverse of f of x. Now remember, this form f inverse doesn't cancel the f only when you are restricted. They cancel each other when this f inside it is restricted. Now, is this pi over 3, is it in the restricted domain of the sign? Yes, it is from negative pi. So in this case, these will cancel each other and the result will be pi over 3. Now let's check this case. Sine of sine inverse root 3 over 2. Now, for this to cancel this must be in the domain of sine inverse. The domain of sine inverse, this must be from negative 1 to 1. Is it from negative 1 to 1? Yes, so the result, it will cancel each other, it will be like this. What about this one? Can I cancel the sine inverse with the sine in this case? Now this is like this one. The f inverse doesn't cancel the f only if f is restricted. Is this number, is this angle in the restricted domain of the sine? No. So that will not be 3 pi over 4. It will not be 3 pi over 4. Why? Now it is obvious here. The sine inverse will never give me an angle that is outside from negative pi over 2, negative pi over 2. And check it with the calculator. It will never give me an angle that is 3 pi over 4. But what angle would it give me? Now this 3 pi over 4 is this angle. This is this angle. Remember that the sine inverse is an angle which is in this quadrant or this quadrant. Okay? So it will give me another value which is confined, or an angle that is either in this one or this one, which have the same sign of this angle, 3 pi over 4. What is the sign of this angle, 3 pi over 4? This is the sign. Remember, the sign is the y coordinate of the point. Okay, for this angle, when you study angles by the unit circle. The unit circle, x and y are cosine theta and sine theta.
135.
Yes, 135. This is exactly 135. 135. What is its sign? What is its sign? What is this value? It is just depicted on the graph. It will be this length. This is sine. This is sine of 3 pi over 4. Okay, I need to find an angle which have a similar sign, but in either in this quadrant or this quadrant. What angle that have an exactly equal sign? This angle. Yes, 45. This angle will have this sign, and this will have this sign. So this will be pi over 4. The result of this, the right result of this will be pi over 4, which is this angle, this green angle. It's an angle which is in the first quadrant that has the same sign of the 3 pi over 4. Okay? Okay. Now if I have a problem, find the domain of sine inverse x squared minus 1. How to find the domain of this function? I take what is inside, find the domain and range. I take what is inside the sine inverse and take it like this, x squared minus 1 from negative 1 to 1. I've learned that what is inside the sine inverse must be from negative 1 to 1. Now I solve this inequality. That will be x squared from, I add 1, so that will be 0, and that will be 2. Now remember, if I had a bracket all squared, I can take the square root whenever these are not negative. So I'll take a square root, so that will be 0. What is square root of x squared? Absolute x. Absolute x is greater than or equal to 0. This is known, and that will be solved. X is from negative root 2 to root 2. So this is the result. What if I had sine inverse of x squared minus 3? I need to find the domain. Find domain. X squared minus 3. I take it from negative 1 to 1. Now x squared will be from, add 3, so that will be 2, and that will be 4. I can take absolute x, I take the square root, so that will be from root 2 to root 4, which is 2. Now I have two inequalities. This is meant to be absolute x greater than root 2, and at the same time absolute x is from negative 2 to 2. Absolute x, that will be from negative 2 to 2, and that will be x greater than root 2 or x less than negative root 2. If you remember how to solve inequalities with absolutes. So that will be x from negative 2 to 2, that will be like this, negative 2 to 2, this part. And if I make this red, so root 2 is less than, that will be root 2 and negative root 2. So that will be this, and that will be this part. So what are the intersections? And all of them are closed. All of them are closed. All of them are closed like this. So what is the intersection? The intersection will be this part and this part. So what is the domain in this case? It will be from the negative 2 to negative root 2 union with root 2 to 2. So this is the domain in this case. Okay? Okay. What if I had sine inverse x squared plus 2? X squared plus 1. Plus half. So x squared plus half will be from negative 1 to 1. So x squared will be minus 3 over 2, and that will be half. I need to take the square root. Can I take the square root with this? No. But this part of the inequality, it doesn't give me information. X squared is a positive number. It is always greater than or equal to a negative. So I can dismiss this part. So this will be just x squared less than or equal to half. And that will be absolute x is 1 over root 2. That will be the result, or x from negative 1 over root 2 to root 1 over root 2. Okay? What about if I need to find the range of this function? How to find the range of a function? A range of function, we have only learned one method to find the range, is by graphing the function. Maybe you have learned some functions. You may make some transformations of functions to find the graph. Okay. So we only learned the graphing function, the graphing of a function. You may make use of the transformations of functions to make the problem simpler. Okay. Another way to find the range of some function is just the domain of the inverse. So one way to find the range is to find the inverse function, then you find the domain of the inverse function. Okay? So if he tells me I need to find the range of this function, so my goal will be to find the inverse function first. So how to find the inverse function? So this is y is equal to sine inverse x squared minus 1. I will change x and y. So that will be x is equal to sine inverse y squared minus 1. Now I need to get rid of this. I need to find the y in one side. I need to put the y in one side. I need to get rid first. I need to get rid of this sine inverse. How to get rid of a sine inverse?
Take sine first.
Yes, take sine. But the ordinary sine, what is the inverse of sine inverse? Is it the ordinary sine or the restricted sine? It is the restricted sign. Remember that the sine by itself doesn't have an inverse. The ordinary sine doesn't have an inverse. What is the inverse? The sine. These are inverse to each other. Sine restricted and sine inverse. These are the two functions that are inverse to each other. When I tell you what is the inverse of sine restricted, you will tell me sine inverse. What is the inverse of sine inverse? You will tell me the sine only? No, it is sine restricted. It is sine restricted. Okay? So, how to get rid of this? I will take sine restricted both sides. I will take sine restricted both sides. So that will be sine restricted x equal to y squared minus 1. And that will be y squared will be equal to sine restricted x plus 1. Now I take the y. I take the square root of that y, which will be, I will take the positive root or the negative root. I'll take just the positive. Yes, I'll take just the positive. Why? Because this is not a one-to-one function. By itself, this is not a one-to-one function. You must put a condition that x is greater, because I have an x squared here. So I needed to put a restriction of the domain at first. Then I solved for it. So when I got to this step, I just took the positive because I've done this condition. So that will be sine restricted of x plus 1. What is the domain in this case? What is the domain? So this is the f inverse. What is the domain of f inverse? It is the restricted sign. So that will be from negative pi over 2 to pi over 2, which is exactly the range of f. Which is exactly the range of f. Okay? In a similar procedure, we will find the inverse of the cosine. We have the cosine inverse x. Cosine inverse x. The cosine is like that. What is the restricted domain of cosine? It will just take this one. So a restricted domain, cosine restricted, the domain will be equal to from 0 to pi. In this case, it will be from 0 to pi. And the range is ordinary from negative 1 to 1. So the cosine inverse will have a domain of from negative 1 to 1, and will have a range which is equal to 0 to pi. So what is the cosine inverse? A cosine inverse, if I tell you cosine inverse of 1 over root 2. Cosine inverse is an angle that has a cosine equal to 1 over root 2 and in this interval. What is 0 from 0 to pi? It is the first and second quadrant. First or second quadrant. First or second quadrant. So what is a cosine inverse? It is a cosine inverse. It is an angle that has a cosine equal to 1 over root 2 and is in the first or the second. It just has one value. Cosine inverse has just one value. Is the cosine inverse, is it an even function? No, never. An even function, the inverse of an even function is a general function, not an even function. Why? Because when you have an even function, an even function is not one-to-one by itself. An even function by itself is not inversible. Any even function is not inversible. Why? Because it's not one-to-one. So you need to restrict it. So when you restrict it, you don't have a symmetry in this case. So it will just be general function. Okay? So when you find the inverse of this restricted cosine, it will be something like that. It will be something like that. It is just a reflection about, maybe it is not very precise, but it is something like that. Anyway, okay, it is like this. This is cosine inverse. Cosine inverse, it is obvious. It doesn't have a symmetry about the y-axis. Neither it has a symmetry about the origin. And that's why there is a rule that we need to remember, that cosine inverse of minus something, it is pi minus cosine inverse of that thing. So this rule must be Memorized. This is an important rule, memorized. So when I say what is cosine inverse negative 1 over root 2, this is pi minus cosine inverse 1 over root 2. And this cosine over this will be pi over 4. So that will be 3 pi over 4. And the result is from 0 to pi, so it is satisfied. What about what is the domain of 3 cosine inverse 2x? Find the domain and range. Find the domain and range. The domain is simple. The domain is simple. You take 2x from negative 1 to 1. You take it from negative 1 to 1. So that x will be from negative half to half. What about the range? We have learned 2 methods. First is the graphical. And graphical, if you make it by the graphical method, it will be simpler. Okay? Now just remember, if you have a linear function of x in the cosine, it will have much a similar graph, just like the cosine inverse. Why? Because it's just a scaling. Do you remember this? When you take every x, you put x to x and some shift, some horizontal compression, horizontal expansion, horizontal shift, all of these are transformations on the x. It doesn't matter. Why? It doesn't change the range. If you make any transformations on the x, does it change the range? No. So that's why whenever I have this 2x, or whenever I have a function of x or a transformation of x, I know the graph, its graph will not change from the graph of or the range of cosine inverse x. So I know that the cosine inverse x is, the result of cosine inverse x is always from 0 to pi. If I multiply by 3, what would happen? I would have a vertical expansion. So this will be multiplied. If I multiply by 3 cosine inverse x, or make it 2x, that will be from 0 to 3 pi. So the range will be from 0 to 3 pi. From 0 to 3 pi.
The inverse of the domain.
The inverse of the domain. No, the domain here is from negative pi over 2 pi over 2. Or you mean finding the domain of the inverse? You mean finding the inverse first? Then yes, this is another method. But now I am making it with a graphing method. Or this is called the inequality method. By just knowing that the cosine inverse by itself is from 0 to pi. So multiplying by 3, this function will be in between the 0 and 3 pi. I will just tell you the tan inverse, then we will have some problems and maybe you are okay. If I have y equal to tan inverse x, the tan is like this, pi over 2, negative pi over 2, and the graph of the function is like this. What is the restricted domain of, what is the tan restricted? Tan restricted will be, I will make it in red. Tan restricted, I will just take one branch of it. So that tan restricted is, its domain is from negative pi over 2 to pi over 2. Its domain will be from negative pi over 2 to pi over 2. But this is open. Because negative pi over 2 and pi over 2 are not in the domain but of the tan itself. Okay? What about the range? The range will be R. What is the graph of tan inverse? It will be something like this. It is like this. Tan inverse is an odd function. Why? Because the tan is an odd function, so its inverse is odd. So its inverse would be odd. So if I say f of x is equal to tan inverse x cubed, what is the domain in this case? We have said what is inside. What is inside? The tan inverse must be from negative pi over 2 to pi over 2, but it is open. It is just like the sign, but it is open. So that I will take the cubic root both sides, so that will be x from root negative pi over 2 to root cubic root to cubic root. And the negative would be aside to negative 3 root over pi over 2 and cubic root pi over 2. Pi over 2, yes. Cubic root. So this is the domain. What about the range? We have made here a transformation in x. So it doesn't change, it will be r. That will be r. Okay? But if I say tan inverse x squared, what would be the range of tan inverse x squared? When you say tan inverse x squared, now remember this is the tan, or this is the tan inverse. This is the tan inverse, it is like this. Tan inverse is like this. If I make the input x squared is always positive. X squared, the result of x squared is always positive. So that's why the input of the tan inverse will never be negative. So what would be the graph of this function? It would be تقفلي علينا ولا ايه؟ هتحبسينا؟ Yes, only the positive. Yes, in this case it would be only the positive. Just little examples. If I have cosine inverse of sine x over x cubed and tan inverse of cosine inverse x squared over sine inverse x, I need to find if these are odd or even functions. Odd or even functions. Now this is odd. Sine is odd. What about x cubed? Odd. Odd by odd is even. Negative over negative is positive. So that is even. So now I have now cosine inverse of even. The cosine inverse by itself is, do you remember, it's general. Yes. An even function, an inverse of an even function is general. So that will be general. And that's why the square root is general. Because it is an inverse of an even function, which is x squared. X squared is an even function. X squared is an even function. We know that. What is its inverse? Its inverse is root x and it is general. What about this x cubed? It is an odd function. What is inverse? Cubic root of x. An inverse of an odd function is an odd function. So this is odd. Now let's check this. A general function and we have inside an even function. What would be the result? Do you remember? If I have inside an even function, the even function dominates the whole thing and it will be even. So this function is even. Let's check this. Let's check this. Cosine inverse, this is x squared. X squared is even. Even inside the general, it will be even. So this is even. This is sine inverse x is odd. Even over odd will be odd. So I have here tan inverse of odd. Whenever I have the inside function is odd, whatever it is just like the outer function. The outer function here, what is tan inverse? It is odd too. So the whole result will be odd. If the inside function is odd, the result is as the outsider function. It is as what is the outsider? It is tan inverse. Okay. We have here two topics that we haven't we have the simplification and the differentiation. Maybe they will take 20 minutes. Next time we will meet, but exactly, we'll make it exactly 3:50, okay? To substitute for these topics, okay? Simplification of inverse and differentiation of inverse functions. Next time, today I've arrived a little bit late, but next time I'll get early, okay? كفاية كده.